Welcome on my channel. As you know, over the past few weeks, I've been preparing an exciting journey where we'll explore the world of artificial intelligence and machine learning, one step at a time. To keep things efficient, you'll always have timestamps so you can jump straight to what matters most. If you're new here, here's what you need to know. Unlike other channels, my goal isn't to keep you binge-watching tutorials. Instead, I want to get you building as soon as possible. That way, we can grow together as a strong community, ready to make a real impact in the world. Studies show that the best way to learn is through repetitive practice and testing. To help you with that, I've structured my tutorials like this. First, we'll break down the concepts in the simplest way possible, making sure you understand each step clearly. After that, you get an exercise file, linked below, so you can start practicing immediately. The exercises start easy and gradually get more complex, challenging you to research and experiment, because that's how you truly level up in coding. So, are you ready? Let's build something amazing! Since you're here, I won't waste your time explaining what Python is or why it's important. You already know that, so let's jump straight into the action. To run Python, we first need to install it on our system. Head over to python.org, go to the Downloads tab, and grab the latest version for your operating system. In my case, that's Windows. The installation process is super simple, just like any other software. An installer will open, and you can stick with the default settings. However, don't forget to check the Add to Path option. This little step will save us from headaches later on. To write code efficiently and avoid unnecessary frustration, we use something called an IDE, Integrated Development Environment. This is a software application that helps developers by combining essential tools like code editing, building, testing, and debugging in one place, making coding much smoother and more productive. There are plenty of IDEs to choose from, but my favorite is VS Code, and that's what I'll be using in this series. If you prefer another IDE, no worries, you can still follow along without any problems. But if you're just starting out and want to install VS Code, here's how. First, navigate to the official VS Code website and download the latest version for your operating system. Once downloaded, feel free to go with the default settings and launch it when you're ready. The VS Code is a very complex IDE but still beginner-friendly, and if you wish for a more in-depth presentation of its interface and features, let me know in the comments below. I will gladly do that. But all you need to know for this video is how to add a folder. The simplest way is to drag and drop it into the main section here. Once done, you can check the Explore section over here, which you can toggle by simply clicking its icon. Here, you can see and manage the files and folders inside the working main folder. Of course, you can add folders, files, and refresh by simply clicking the icons on top. If, by accident, you move folders or files around, simply drag and drop them to the desired place. The most important section is the terminal. To display it, simply navigate to the top menu here, over the Terminal section, and click New Terminal. If you've never used a terminal before, I will show you the main uses so that you can work with me. Again, let me know in the comments if any of you need a more in-depth explanation of how the terminal works and the main commands we use. So, when you first open the terminal, you'll be located in the main folder. In our example, we have Python 101 with an episode 01 folder inside. Inside episode 01, there are 3 more folders and each folder has its own files. Let's say we want to open exercise1.py from the recap folder. To do so, a very easy beginner approach is to right-click the folder, click on Copy Relative Path, then go back to the terminal and use the cd command and press Ctrl+V to paste the path. Just hit Enter, and you are in the right location. Here we have a lot of Python files, and you'll know they are Python files because they all have the .py extension. Since we installed Python earlier, we can simply use the Python command followed by the file name and press Enter. And voila! You've just run your first Python script. But what if you need to go to the exercise or reinforce directory? Well, for this, you need to navigate back, and the command for this is cd followed by 2 dots. Then, use cd again to navigate to your desired location. Remember, cd plus 2 dots is used to go backward, and cd plus a folder name is used to navigate forward. In Python, comments are special lines of text that the computer ignores when running the code. They are useful for adding explanations, notes, or reminders without affecting how the program works. To write a single-line comment, you use a special symbol called hashtag at the beginning of the line. Everything after this symbol on the same line is treated as a comment and won't be executed. You can place it at the start of a line to describe what follows, or even at the end of a line after some code to explain what that specific part does. However, if you press Enter and continue on a new line, Python will treat that as regular code unless you add the symbol again. For longer explanations, you can use 3 apostrophes at the beginning and end of your text. This allows you to write multiple lines of comments without needing to add a special symbol at the start of each one. This method is also commonly used for documenting functions and larger sections of code. By using comments properly, you can make your code much easier to understand and maintain, whether for yourself or for others reading it later. Think of variables as small boxes where we store things, except instead of toys or snacks, we store data values. These boxes can hold different types of things, but in Python, we mainly use 4 types. Strings for text, integers for whole numbers, floats for decimal numbers, booleans for true or false values. Unlike some other programming languages where you have to declare a variable type, Python is smart and figures it out on its own. That means you don't have to say, "Hey Python, this is a number," or "this is text." It just knows. Making a variable in Python is as simple as choosing a name and assigning a value with the equal symbol. We can choose name for the variable, this case, name, followed by equal sign for assigning and the value we desire, like Alice, and since it is a string we can use double quotation marks. Easy, right? But before we dive deeper, let's open each box one by one and understand what's inside. A boolean can only be true or false, like an on-off switch. To assign a boolean, we need to choose a name. For an easy example, let's try is student, followed by equal sign, and switch it off by using false, or on by using true. Here you need to pay attention that boolean are key sensitive, so false with capital F is not the same with false, and Python will return an error, since booleans have always capital letter first. Let's try some examples. If we print 10 greater than 5, it returns true, since 10 is indeed greater than 5. But if we print 3 equals 5, it returns false, since 3 is not equal to 5. And if we print Alice not equal Bob, it returns true again, since Alice is not the same with Bob. For sure you noticed I used 2 equal signs here, because in Python 1 equal is used to assign values, but 2 equal signs are similar to mathematical sign equal. And for sure you also noticed the exclamation mark used here. In most languages, including Python, exclamation sign is similar to the word not, which means not equal. To make things clearer and help you avoid feeling like you need to memorize everything, I'll provide a cheat sheet in the description below. You can use it confidently during the practice section. Shortly, you'll be able to recall these signs effortlessly. Now, it may sound overcomplicated using booleans in this easy example, but mastering booleans variable will be very useful for decisions and conditions in Python. You see, booleans have only 3 operators: the words and, or, and not. Using this, you can write very complex conditions. I will show you a few examples, but don't worry if it does not make sense immediately. We will come again to Boolean conditioning as we will dive deeper in flow control in the next videos. But until then, here is a short explication. Let's take 2 variables. The first one called is tired equals true, and second one has homework equals false. Now if we plan to use the word and, both variables need to be true in order to return true, since in our case his homework is false. The output will also be false. But if we change has homework to true, the output will also be true. Let's change has homework back to false, and let's try it now by using the word or. You see, in this case, even if one variable is true and one variable is false, the output return true, because when using the or word, only one condition need to be true. A little different job makes the word not. Whatever your original value is, when using not word, the value will be reversed. In this case, if is tired originally was true by printing this using the word not first, now became false. But don't worry, it is changed only for this print. If we call the variable once more, time without the not word is again true. Now let's take a look at integer and float variables. Both are similar, with the main difference being that integers are used for whole numbers, while floats are used for decimals. In this example, age equals 25 is integer, and heights equals 5.7 is float. But as we know, Python loves math. By using integers and floats, you can perform all kinds of operations: addition, subtraction, multiplication, division, floor division, modulus, and even exponentiation. You can also mix integers and floats together. Let's break these down step by step, using variables to illustrate. We take a variable x and assign it to 3, and a variable y and assign it to 5. Now, let's look at each operator. For addition, we use the plus sign. So if we have x equals 3 and y equals 5, we do x plus y. This results in 8 because 3 plus 5 equals 8. So the output is 8. Then we have subtraction using the minus sign. So if we do x minus y, we get 3 minus 5, which equals -2. The output is -2. Next, for multiplication, we use the asterisk sign. So x asterisk y gives us 3 times 5, which equals 15. The output is 15. For division, we use the slash sign. So x slash y results in 3 divided by 5, which equals 0.6. The output is 0.6. Now, floor division is a bit different. We use the double slash sign. Floor division divides the numbers and rounds down to the nearest whole number. So x double slash y results in 3 divided by 5, but instead of 0.6, it rounds down to 0. The output is 0. Then we have modulus, which uses the percent sign. Modulus gives us the remainder after division. So x%y is 3 divided by 5, and the remainder is 3 because 5 goes into 3 0 times, leaving 3. The output is 3. Finally, for exponentiation, we use the double asterisk sign. Exponentiation raises the first number to the power of the second number. So x double asterisk y is 3 raised to the power of 5, which equals 243. The output is 243. These are the operators, and you will try them all with the exercises I've prepared for you, but before, let's also take a short look at strings. A string is just a piece of text, always wrapped in quotes, double or single. So, we have name equals Alice, and message equals hello world. Just like integers can do math, strings have their own special abilities called methods. Let's take the message variable as an example. To use a method, simply type the variable name, add a dot, and choose the method you want from the list. Let's test the upper method. Run the Python script once more, and as you can see, it converts the text to uppercase. However, keep in mind that methods don't change the original variable, they only transform it for that specific call. If we call the message again without the method, it will return to its original form. But if you want to permanently change the variable, you need to reassign it. In this case, you first take the variable, use the equal sign to assign it again, and then write its name, followed by a dot, and choose your desired method, exactly like this. Don't forget the parentheses. Now, if we simply print the message, it will be in uppercase without using the method inside the print function. Actually, now it will always be uppercase, since the variable holds the updated value. In Python, we can make our programs interactive by asking the user to enter information. This is done using a special function called input that allows us to take input from the keyboard. When we ask for input, the program pauses and waits for the user to type something. Once they press enter, the input is stored, and we can use it in our code. Are you curious how to build powerful inputs in your code? Well, let me show you. An input starts like any other variable. We first need to choose a name for the variable that will store the user's response. After that, we use the equal sign to assign the variable, and then we call a special function. As we already know, its name is input. Since it is a function, it needs parentheses to take input from the keyboard. Now run the script and see what happens. Nothing? Well, something did happen. The script ran and followed each line until it reached the input function. At this point, it paused, waiting for us to type something. Once we enter any text and press enter, the script continues executing each line one at a time. But this input isn't really useful yet, right? The user has no idea what's happening. So, let's improve it by adding a message before the input function. To do this, we place double or single quotes inside the parentheses of the input function. Inside the quotes, we write a message that tells the user what to enter, and then we run the script again. Python is smart enough to figure out where our text ends and where the input begins. Almost perfect. Now that we have a variable storing the user's input, would you like to use it in your code? Here's how. Let's say we have the user's age, and we know we are in the year 2025. We can easily calculate their birth year by subtracting their age from 2025.
And oops,
we got an error. If we carefully read the error message, we notice that Python is telling us we can't combine a string and an integer. Why does this happen? Well, by default, Python treats all inputs as text, even when the user enters numbers. This is because Python doesn't assume what the user means. It keeps everything as a string to prevent unexpected errors. But don't worry, we can fix this easily. Let's find out how. So, how do we fix this? Simple. Since we know the input should be a number, we need to convert it. To do this, we go back to our age variable and, right before the input, we specify the type we want, integer in this case, since age will always be a whole number. To make it work, we open parentheses and double close them at the end, first for input and then for integer. Now, the age variable can only accept whole numbers, and with this fix, we can do the math and find out that the user was born in 2000. But what happens if you try to put something else in the input, like a float or a string? Python will crash and give us an error, value error, invalid literal for int. As we move forward, I'll show you how to handle such errors so that instead of crashing, you can inform the user about the mistake and let them try again. But until then, you've made great progress. Even though it may not seem like much at first, you now know how to write and run small scripts. Are you ready to tackle the exercises I've planned for you? It will take a little time and you may run into some errors along the way, but this is the right way to learn programming. Watching tutorials alone won't take you far, but practicing will. So, whenever you're ready, grab your cup of coffee or tea, grab the exercises, and get started. In the description below, you have 2 methods to get the exercises. First method, navigate to my GitHub link, click on download, unzip the archive, and then simply drag and drop the entire folder into VS Code. Second method, join my Discord server, head to the practice section, and download the zip file. Again, unzip it and drag and drop the folder into VS Code. In the Explorer tab, which you can open and close by clicking the first icon, you'll find a folder called Day, followed by the learning day we are in. Inside this folder, there are 3 subfolders. The first one is called Exercises, and I recommend you get started with this right away. The second folder is called Recap, and I suggest you wait until tomorrow to go through it. Giving your brain some time to process everything you've learned today will help reinforce your understanding. In fact, studies show that sleep plays a huge role in consolidating new information, so sleeping on it could help you recall the concepts more easily the next day. The third folder is for after a short break. Take a day off before tackling the next set of exercises. This will give your mind a chance to recharge and come back with fresh energy. Taking breaks in between learning sessions is really beneficial for long-term retention and keeping motivation high. Don't worry, when you get back, the exercises will be a little more challenging and will need a bit more research, but I'm confident you'll do great. You'll also have lots of hints along the way to guide you through. And remember, if you ever need help, don't hesitate to reach out to me in the Discord channel. I'm always happy to support you as you progress. if-else statements, and logical operators. These are the building blocks for decision-making in your code. As we learned in the first video, Python executes each line of code one by one. But what if we need to skip some lines based on certain conditions? Well, this is where flow control comes in, like an if-else statement. The definition sounds like this. An if-else statement allows you to control the flow of your program by making decisions based on a condition. You're telling your program to execute specific code only if a certain condition is true, and to do something else if it's false. Now, to understand better, let's try a real-life analogy. Think of it like writing a smart weather app. As a developer, you want your app to tell users what to wear based on the temperature. If it's cold, like below 10 degrees Celsius, the app suggests, wear a jacket and a scarf. If it's warm, like above 20 degrees Celsius, it says, t-shirt and sunglasses time. But if the temperature is in between, the app might say, a light sweater should do. Just like this, if-else statements help your code make smart decisions based on conditions. The basic structure of an if-else statement is as follows. The if keyword is used to define the condition that we want to check. The code that follows will execute only if the condition evaluates to true. The else part defines what happens when the condition in the if statement is false. The code after else will run when the condition is false. Python relies on indentation to indicate which block of code belongs to the if statement and which belongs to else. This is different from many programming languages that use curly braces to mark code blocks. If the indentation is wrong, like using inconsistent spaces or mixing spaces with tabs, you'll get an indentation error. Would you like a real example? As usual, we first need to set up a variable. In a more realistic scenario, it would be retrieved through an API or user input. But since we need to walk before we run, we will manually set and change it. So, we set temperature equals to 40 degrees. In our weather app example, we first want to check if the temperature is over 35 degrees, meaning it's risky hot. In this case, we use the greater than operator. If the temperature is greater than 35, then the block of code inside the if statement executes. So, in the indented part, we'll place a print function with a warning message like, it's a hot day, drink plenty of water. When we run the script, the warning message appears because 40 is greater than 35. But what if we change 40 to 35? Oh, nothing happens. Did you spot why? It's because we set temperature equals 35, but the condition checks if the temperature is greater than 35. Since 35 is not greater than 35, the if condition evaluates to false, and the program skips the if block. It then moves to the else statement where nothing is set. So, let's build the else statement too. We add another print function with the message, it's a cool day, wear a jacket. We run it again, and it works. The condition temperature greater than 35 is not checked. Since 35 is equal to 35 and not greater, the program print the else statement, since this is true. It all sounds good in theory, but is it really true? I mean, yes, theoretically it is, but 35 degrees is still a pretty hot day, right? So, what can we do? We could try to find a middle point in the temperature, but in real life, we don't just have risky hot and cool days. No single degree difference will drastically change whether you wear a jacket or face extreme heat. That's where Python provides the perfect solution, adding multiple conditions. We can define multiple blocks of code that execute when different conditions are met. This is done using elif, short for else if. And the best part? We can add as many elif statements as we need. So right after the if statement, we build our new elif exactly the same way as if. Let's do this. We place the magic word elif, add the condition, temperature greater than 20, put double points, and in the indented block, we add the print function. Or, in the future, the action we need to take in this case. But for now, we only print it's a warm day. Now the app works like this. If temperature greater 35, the program prints it's extremely hot, so drink a lot of water, and then ends its execution. Next, if the first condition is false, but temperature is still greater than 20, second condition is true, so it prints it's a warm day, and after this ends its execution. Lastly, if both conditions are false, the script navigates further to the last block. So temperature is below 20, it prints it's a cool day. Wear a jacket. And only then ends its execution. We see it's still not entirely true since we don't really wear jackets at 20 degrees, so let's add one more statement. We place again the same magic word elif. We add the condition, this time temperature greater than 10, so this condition will be true only when the temperature ranges between 11 and 20. In the indented block we place the print function with the message, it's a cool day. A hoodie could be needed. And when all three statements are false, the last block will be executed. Only when temperature is under 10 degrees and a jacket is indeed necessary. You can take some time to experiment with different temperatures to see if the logic works correctly and if any improvements are needed. So far, we've been using the greater than operator to compare the temperature, but there are many more comparison operators that you can use to compare different values. Let's take a look at some of the most common ones and how they work. Equal to. This operator checks if two values are exactly the same. If they are, it returns true. For example, if the temperature is exactly 5 degrees, we can use the equal to operator to see if it matches. So, 5 equal to 5 would be true. This operator can also be used with booleans. If a variable holds a boolean value, you can compare it with true or false using the equal to operator, like is student equals true. However, you can also simplify this check by directly using the variable in the condition, as it will evaluate to true or false automatically.
Not equal to.
This checks if two values are not the same. If they're different, it returns true. For example, if we have a temperature of 5 degrees and we want to check if it's not equal to 3 degrees, we can use the not equal to operator. So, 5 not equal to 3 would be true. Greater than. This operator checks if the value on the left is larger than the one on the right. For instance, if the temperature is 7 degrees and we want to know if it's greater than 3 degrees, we use the greater than operator. So, 7 greater than 3 would be true. Less than. This operator checks if the value on the left is smaller than the one on the right. For example, if the temperature is 4 degrees and we want to check if it's less than 9 degrees, we use the less than operator. So, for less than 9 would be true. Greater than or equal to. This checks if the value on the left is either greater than or equal to the value on the right. If it's 5 degrees and we want to see if it's greater than or equal to 5 degrees, we can use the greater than or equal to operator. So, 5 greater than or equal to 5 would be true. Less than or equal to. This checks if the value on the left is either smaller than or equal to the value on the right. For example, if the temperature is 3 degrees and we want to check if it's less than or equal to 4 degrees, we use the less than or equal to operator. So, 3 less than or equal to 4 would be true. With these comparison operators, we can compare numbers, text, and other values in Python. For example, in our weather app, we might want to check if the temperature is not just greater than 35 degrees, but also if it's exactly 35 degrees. So instead of just using the greater than operator, we could use equal to or greater than or equal to handle different situations more precisely. Now, let's explore how these logical operators work and how you can use them in your code. The AND operator is used when you want both conditions to be true for the code to execute. Imagine you're building a weather app and you want to check if it's hot and sunny. You would only want to go outside if both of those conditions are true. For example, if the temperature is 30 degrees Celsius and the weather is sunny, both conditions are true, so the action will happen. If either one of them is false, for example, it's hot but not sunny, the action won't be executed. The OR operator is used when at least one of the conditions must be true for the code to run. In the weather app example, you might say, if it's hot or sunny, go outside. Even if only one of these conditions is met, the action will still happen. So, if it's hot but not sunny, or if it's sunny but not hot, the code will still run because one of the conditions is true. The not operator reverses the result of a condition. For example, if it's not raining, go for a walk. If the condition is false, if it is raining, not will make it true, and the code will execute. If it's not raining, then the not will turn that condition false, and the code will skip the action. With logical operators, you can combine multiple conditions to create complex rules for your code. They allow you to evaluate several conditions at once and decide what to do based on them. For example, in our weather app, we might use logical operators to handle multiple factors like temperature, sun, and rain. This makes your code more powerful and flexible. Now, we understand if-else statements, but there will be a hard moment in your journey as a new developer when these conditions will not be enough. You will need to check conditions within another condition. But luckily, Van Guido already met this challenge and built us the perfect way to tackle it: nested conditions. Simply put, these are if-else statements inside another if, elif, or else block. This allows us to make more detailed decisions based on multiple factors. The basic structure of a nested condition looks like this. We are already familiar with the if-else structure, but what's new here is that inside the else condition, we indent another if, elif, and else block. So, in this script, the program will first check the first if statement. If it's true, it ignores the rest of the code and ends there. If it's false, the program moves into the else block, and here it starts checking the conditions again.
First, it checks the if statement again.
If true, it ends there. If false, it moves to the elif, checks that, and if that's also false, it goes to the final else block. Before we dive into our example, it's important to remember that nested conditions can appear not just inside the else block, as we'll see in our example, but also inside an if or elif block. It's a flexible tool that lets you build decision trees at any level of your logic. For our current example, we'll focus on using nested conditions inside the else block because it fits the scenario, but keep in mind that you can apply this pattern anywhere in your code. To better understand, I created an old-fashioned password checker. Of course, in real life, we would use more advanced techniques and achieve the same result in less than 5 lines, but this example should help you learn and understand the concepts more deeply. By the way, pay close attention because by the end of the video, you will get multiple exercises like this to solve. Solving them will help you understand the syntax better, and your brain will start developing problem-solving skills, which are crucial for every developer. Now, let's dive into the exercise. In this example, we'll build a script that checks if the password is secure and hard enough. We'll start by taking an input from the user and saving it in the password variable. Do you remember how we do this? Choose the variable name, password, followed by the equal sign, and invoke our beloved input function. We should also add a message, so the user knows what to provide. Please enter your password to check. Now that we've saved the password, we can use the variable in our conditions. The first scenario we'll check is whether the password is shorter than 8 characters. If it is, we print, "Password is too weak. Choose one with at least 8 characters." But which operator should we use for this check? We need to know the length of the password, so we'll use a built-in special function called len, followed by parentheses, because it's a function, and inside the parentheses, we'll put the variable we want to check, password in this case. What this function does is calculate the length of the string, each character in the password. In this case, we'll use the less than operator because if the password is less than 8 characters, we want to close the script and ask the user to try again. But if it's longer than 8 characters, we'll move to the else block and check other things, like if the password contains numbers or if it has lowercase letters. In the else statement, as we see, we need to build another if statement. Since the password in this scope will always be longer than 8 characters, we now need to check if it contains any number. To do this, we will use a special method this time, isdigit. Do you remember how the method syntax works? For the if condition, we place the password followed by a dot, and then the method isdigit. Don't forget the parentheses. It looks a bit different, but this is it. This is our condition. I told you Python is smart. Here's how it works. Since we don't put any operator here, it only checks if the variable contains digits. Actually, it checks if the password is made up entirely of digits. So, if your password is something like 1, 2, 3, 4, 5, 6, 7, 8, it will activate this if statement. But if the password also contains letters, the statement will be false, and it will move on to the elif block. In the elif block, we want to check if the password contains both uppercase and lowercase letters. For this, we will use a simple trick. We'll call the lower method and compare this to the original password. If both are the same, it means the password only contains lowercase letters, but if it's false, this block will also be false, and the program will move on to our desired block, the else statement. How do we do this? We first call the variable add the and look for the lower method. I'm sure you remember this from the exercises you've done. Now, we use the equal operator, double equals, don't forget. We compare the result against the original password. And that's it. Feel free to test the script with different passwords. Also, don't worry, the main skeleton will be displayed in your exercises, and you can redo this process once more. Speaking of saving time, today's episode is all about loops, your secret weapon for handling repetitive tasks like a pro. Let's dive in. A loop is a programming structure that allows you to repeat a block of code multiple times. Loops help in automating repetitive tasks without writing the same code again and again. Python provides two types of loops, for loops and while loops. But how are they different, and when to use each one? A for loop is perfect when you already know how many times you want to repeat an action. Instead of writing the same code multiple times, a for loop does the work for you, automating repetition in a clean and efficient way. Let's say you want to print hello 5 times. Instead of writing print hello 5 times, you can easily use for loop to make the job. It might look a bit confusing at first, so let's break it down. Range 5 create a sequence of numbers from 0 to 4, and this means the loop will run 5 times because there are 5 numbers in the sequence. The I is a loop variable that takes one number at a time and runs the code inside the indented block, which in our case is the print function. In this sequence we have first, I equals 0, so the print function will run first time. Then the loop is repeated, so this time I equals 1, and the print function runs once again. The same process repeats until the last element in the sequence is reached, causing the print function to run a total of 5 times. Instead of manually writing the print function 5 times, we write it once and tell Python how many times to execute it using the range built-in function in combination with a for loop. In this example, I used the loop variable I, but since it's just a variable, you can choose any name that makes sense for you, like x, y, count, or anything else. In a future video, I'll dive deeper into Python's built-in functions. But since there's such a wide variety, today I'll keep things focused and to the point. Counting isn't the only thing a for loop can do. It can also iterate through lists, tuples, pandas data frames, and much more. Let's take another example. We've created a list called fruits that contains apple, banana, and cherry. Now, we want to print each fruit inside the list in the simplest way possible. Can you think of how to do that? If you want to try it yourself, pause for a moment and give it a shot. Here's how we do it. Just like in the counting example, we first use the magic word for, then specify the condition. In this case, we're looping through each element in the list. Since we named the list fruits, we'll use fruits in our loop. The loop variable can be named each underscore element, but to make it clearer, let's name it fruit. After all, it makes sense that each item in the list represents a fruit. You can choose whatever name works best for you, though, just make it something easy to understand. Finally, inside the indented block, we write the action we want to take. In this case, print fruit to print each fruit in the list. It might not seem too exciting right now, especially since it still involves a bit of work and replacing the print function won't save us much time. But in real-life scenarios, we often work with thousands of rows of data and data frames. Instead of manually sifting through the data to find rows where certain conditions are met, we can use a for loop to automate this process. For example, instead of navigating through a database and checking each student's score to see if it's above 85, we can write a simple for loop to go through each row in the data frame. Inside the loop, we can build more complex actions. If a student's score is above 85, we could print the student's information, create a new list of top-performing students, or even organize them into a separate group. The possibilities are endless. If this feels a bit complicated right now, don't worry. This is completely normal at your level. But you are on the right track, and in just a couple of weeks, you'll be able to iterate through thousands of rows in less than a second. This example is just to give you an idea of the real power of for loops and how they can help you handle large amounts of data more efficiently. A while loop is another type of loop in Python, but it works a little differently than the for loop. While loops are used when we don't know exactly how many times we need to repeat an action, but we know the condition that should stop the loop. The loop keeps running as long as the condition is true, and it will stop once the condition becomes false. When should you use a while loop? Think of a while loop as something that keeps repeating an action until a specific goal is reached or until a condition is no longer true. If you don't know how many times you'll need to repeat the action, but you do know what should stop it, the while loop is the way to go. For example, imagine you are playing a game where you need to guess a number. You don't know how many guesses it will take, but you will keep guessing until you get it right. In this case, a while loop is perfect because you don't know how many guesses, but you know that once you guess correctly, the loop should stop. Here's how you can do this in Python. We start with guess equals -1, or any other incorrect guess, and a while loop that runs as long as the guess is not equal to the correct number. Other words, as long as our condition is true. In this scenario, the loop keeps running until the user guesses the right number, 7. Every time the guess is not equal to the correct number, it prints oops, that's not it. Try again, and repeat the process by asking again to choose a number. When the guess is correct, it prints congratulations, you guessed the right number, and the loop stops because the condition, guess not equals correct number, is no longer true. Be careful. If you forget to update the condition in the loop, the condition may always stay true. This will cause the loop to run forever, known as an infinite loop. For example, if you forget to update the quest inside while loop, the loop will run forever or until you type Ctrl+C keys. To avoid this, always make sure your loop is progressing and the condition will eventually turn false, stopping the loop. Another useful example is a countdown timer. Imagine you need to set a timer that counts down from 10 and stops when it reaches 0. The number of seconds to count down is not fixed by a range, but you know that the countdown must stop when it hits 0. Here's how you could do this with a while loop. Initial setup. We start with a countdown variable and set it to 10. While loop condition. In this case, the while loop needs to continue running as long as the countdown is greater than 0. Action. With each iteration, the countdown is first printed, then its value decreases by 1. Stopping condition. The loop will only stop when the countdown reaches 0, at which point the condition becomes false, and the loop exits. Final message. After the loop stops, we print a time's up message. Example number 3. Keep asking for valid input. Sometimes, when you ask a user for input, you want to keep asking them until they give you a valid response. This is another scenario where a while loop is perfect. In this example, we'll use a while loop to keep asking the user for their name until they enter something valid, a name with more than 2 characters. This is a simple case where we don't know how many attempts it will take, but we know the condition to stop. Initial setup. We start with an empty string. While loop condition. The loop keeps asking for input until the condition is true. Length of the name is greater than 2. Action. Inside the loop, we prompt the user to enter their name using input function, and we update the name variable on the same time to avoid infinite loop. Stopping condition. Once the user types a name with more than 2 characters, the condition becomes false, and the loop stops. Final message. After the loop stops, we print a thank you message with the user's name. Let's recapitulate the main takeaways for Python loops. A while loop is used when you don't know how many times you need to repeat something, but you know when to stop. Be cautious about creating infinite loops by forgetting to update the loop condition. Use while loops when the action depends on a condition, like waiting for user input or counting down to 0. A for loop is ideal when you know in advance how many times you need to repeat an action, typically used with ranges, lists, or other iterable objects. It automatically handles incrementing or iterating through elements, making it concise and easy to use for tasks like processing each item in a list or iterating over a range of numbers. For loops are great for cases where you need to perform a task a specific number of times or loop through elements like strings, lists, or dictionaries without needing to manually update the loop condition. Imagine you're building a city out of Lego bricks, and your task is to create thousands of houses. Instead of painstakingly constructing each house individually, you have a magical assistant named Function. You show him once how to build a house, and from that moment on, he can follow your instructions to build as many houses as you want. The best part? It's as easy as saying, "Function, give me a house," and instantly, a perfectly built house appears. What's more, he's so smart that in more advanced scenarios, he can even learn what elements like windows and doors are. For instance, if you ask him to build a house with large windows and a white door, he can modify the design to match your request, creating something different from all the previous houses that had small windows and brown doors. In Python, a function is a block of code that performs a particular job. Instead of writing the same lines of code over and over again, you can wrap them up inside a function and call it whenever you need it. This makes your code cleaner, easier to read, and much more efficient.
For example,
if you want to calculate the area of a circle multiple times, you don't need to rewrite the formula each time. You can create a function called calculateArea and let it do the work for you. If you're building a game, you might have a function called movePlayer that handles all the logic for moving a character around the screen. Functions are everywhere in programming because they help us organize our code into manageable pieces. They're like Lego bricks, you can snap them together to build something bigger and more complex. The beauty of functions is that once you define them, you don't need to worry about how they work internally. You just trust that they'll do their job when you call them. This is called abstraction, and it's one of the most powerful ideas in programming. Now that we understand what functions are, let's talk about why they're so important in programming. Imagine you're building a house. You wouldn't try to construct the entire house in one go. You'd break the project into smaller, more manageable tasks like laying the foundation, building the walls, and installing the roof. Functions work in the same way. They allow you to divide complex problems into smaller, easier-to-handle pieces. This makes your code more organized, efficient, and easier to troubleshoot. After all, programming is all about solving problems, and functions help you tackle each piece one step at a time. Now that we understand why functions are useful, let's take a closer look at how they're built. Just like a recipe has specific steps, a Python function has a specific structure. Once you understand the structure, writing functions will feel like second nature. Here's the basic anatomy of a Python function. Let's break this down step by step. The def keyword. Every function starts with the keyword def, which stands for define. It tells Python, "Hey, I'm about to define a new function." Without def, Python wouldn't know that you're creating a function. Function name. The name of the function should describe what it does. Good function names are like good labels. They make your code easier to understand. Avoid vague names like doStuff or function1. Instead, aim for clarity, like calculateArea, find largest number, or greet user. Parameters or inputs. Parameters are like ingredients in a recipe. They're the inputs your function needs to do its job. The return statement is how a function sends back its result. Now that we understand the syntax of a function, let's build a simple one together, a function that calculates the area of a circle. If you're feeling confident, take a moment to try it on your own first. Here's a simple way to do it. We start with the def keyword because we need to define the function and let Python know what we're doing. Next, we choose a name for our function. Let's call it calculateArea. Inside the parentheses, we add parameters, and in this case, we need radius because we can't calculate the area without it. Plus, we want it to be different each time we call the function. In the return block, we specify what we want our function to return. In other words, this is where the math happens. We'll use the formula for the area of a circle, pi multiplied by the radius raised to the power of 2. Finally, to call our function, we use it inside a print function and provide a value for the radius to get the result. Since we're already doing some math, how about we try another function, this time with 2 parameters? Let's go ahead and calculate the area of a rectangle. As before, we start with a keyword def, followed by a descriptive name for the function. Let's call it calculateRectangleArea. Inside the parentheses, we list the parameters. Since we're calculating the area of a rectangle, we need both length and width as parameters, separated by a comma. These are essential for the calculation. In the return block, we use the formula for the rectangle's area, length multiplied by width. To test our function, we can call it with two values. Let's use 4 and 6 for the length and width, respectively. After trying out these examples, you should get a feel for how to write functions in Python. However, there are a few important things to keep in mind. First, you can always store the result of the function in a variable. This way, you can either call the variable directly or use the function again later. Second, the return statement is not always necessary. The program will still run even if your function doesn't have one. For example, let's say you create a simple function called sayHello that just prints a message but doesn't return anything. If you try to store the result of sayHello in a variable, it will be none because the function doesn't return a value. Lastly, indentation is crucial in Python. The lines inside the function must be indented properly so that Python knows which lines belong to the function. And here's a key point. You can include multiple lines of code in the function body if the task requires it. For example, you might add error handling or print messages to guide the user. Now, let's dive into something important: keyword arguments versus positional arguments. When you call a function, you can pass values, arguments, in two different ways, by position or by keyword. Until now, we used positional arguments because it's the most common way to pass values to a function. The values are assigned to parameters based on their position in the function call. In other words, the first value goes to the first parameter, the second value goes to the second parameter, and so on. Here's an example. In this case, Alice gets assigned to name and 25 goes to age because of their positions in the function call. The keyword arguments, on the other hand, allow you to pass values by explicitly naming the parameters. This means you don't have to worry about the order of the parameters. Just name them and give them the values. Here's an example. When we call the function, we are not just passing the values, but explicitly using their names and assigning values with an equal sign. By doing this, even though the order is reversed, Python knows which value goes to which parameter because we've used their names. This is especially useful when functions have many parameters, as it makes the code more readable and avoids confusion. Why use keyword arguments? Flexibility. You can pass the arguments in any order. Readability. It's clearer what each argument represents, especially when working with functions that have many parameters. Default values. When a function has default values, you can skip the arguments that don't need to be modified. You can also mix positional and keyword arguments. However, the rule is that positional arguments must come before keyword arguments. Here's an example. In this case, we used positional arguments for name and age and a keyword argument for country. It's totally fine as long as the positional ones come first. Sometimes, you may need to define a function inside another function. This is called a nested function, and it's useful when you have a function that doesn't need to be called outside of the function it's defined in. Nested functions are helpful when you want to organize your code better by keeping related logic together. You want to limit the scope of a function so it doesn't interfere with other parts of your program. You need a function that is only relevant within another function and shouldn't be used independently. In Python, a nested function is simply a function defined inside another function. The inner function can access variables from the outer function, which is known as lexical scoping. Here's an example. In this example, inner function is defined inside outer function. When we call outer function, it also calls the inner function inside it. The inner function can access variables from the outer function. This is especially useful when you want to use the outer function's variables without passing them explicitly to the inner function. For example, here, inner function can access x from the outer function and print its value. Even more, you can also return the inner function from the outer function. This is useful for creating function generators or more complex behaviors. For example, in this case, the outer function returns inner function, which can then be called later with access to the variable x. Summary. Nested functions allow you to define one function inside another. The inner function has access to the variables of the outer function. They're useful for organizing code and limiting the scope of functions. You can return the inner function from the outer function for more flexibility. A lambda function is a small, one-line function that you can create without using the def keyword. It's called anonymous because it doesn't have a name, and it's usually used for simple operations that don't require a full function definition. Here is the syntax for a lambda function, where lambda is the keyword that indicates you're creating a lambda function. Arguments are the input, like the parameters in regular functions. And expression is the single operation or computation that the function performs. In this case, lambda creates a function that adds a and b. We assigned it to the variable add, so now we can call it like a regular function. Why to use lambda functions? Conciseness. Lambda functions are great for short, simple operations that you don't need to reuse elsewhere. Readability. They can make the code more compact and easier to understand, especially when used in situations like sorting or filtering lists. No need for definition. If you just need a quick function for a small task, lambda functions save you from defining a full function with def. Limitations of lambda functions. Single expression. Lambda functions can only have one expression. They can't have multiple statements or complex logic like regular functions defined with def. Not as readable for complex tasks. If the operation is too complicated, it's better to use a regular function. But this is not all. Even tough simple, lambda functions are often used with Python's built-in functions like map, filter, and sorted. Since these topics are a bit more advanced, we will cover them next week. For now, we'll keep things simple until we get more comfortable with the basics. What if I told you that choosing the right data structure could make or break your code? Lists, sets, dictionaries, arrays, each one has hidden strengths and weaknesses. Mastering them is the key to unlocking pandas, and by the end, you'll even be reading and modifying CSV files like a pro. Welcome back. Here we go from zero, all the way to machine learning, together helping technology advance faster. Do you remember the variables from the first video? If not, or if you feel like you need a refresher, I'll put the video in the right corner again. If you do remember, then think about lists as similar to variables. They are containers for storing values. But unlike regular variables, which hold a single value, lists are special because they can hold multiple values at once. You can also think of a list like a shopping list, where you write down different items in one place. Lists are created in a similar way to variables. You choose the list name and assign it with equal sign, but instead of placing just one item inside, you need to show Python that it's a list. You do this by using square brackets and separate the items with commas. In this example, fruits is a list that holds 3 different strings. The interesting thing about lists is that they can contain any type of primitive, integers, strings, floats, booleans, and even a mix of all these types in a single list. Each item in a list has a position number called an index. As you already know, Python starts counting from 0 instead of 1. To access a specific item in a list, you need to refer to its index. The syntax looks like this. We call the list name. Right after we place square brackets and inside brackets, we put the index of the item we want to access. Python has a few built-in functions that help us work more efficiently with lists. Here are the most important ones. Append. This method adds an item to the end of the list. To use it, simply call the list name, add a dot, and then use the append method. Inside the brackets, you place the value you want to add. Insert. This method adds a new value at a specific position in the list. Its syntax is similar to append, but with one key difference. Since insert adds a value at a specific index, you first need to provide the position, index, followed by the value you want to add, separated by a comma. We have also 2 methods to remove values from the lists, pop and remove. The main difference between is that pop requires an index while remove methods uses a value. If we want to delete the second item in the list, we can use pop and place the index 1 inside the parentheses, since Python starts counting from 0. This method is useful when you don't know the exact value of the item, but need to remove it based on its position. On the other hand, if you know the exact item you want to remove but not its position, remove is a better choice. And lastly, as you saw in the last episode, you can use a for loop to iterate through lists. A tuple is very similar to a list, but with one important difference. Tuples are immutable. This means once you create a tuple, you cannot change, add, or remove its items. It's like a list that's locked in place. To create a tuple, you follow a similar pattern to lists. You choose a name for the tuple, and instead of square brackets, you use parentheses. You also separate items with commas. Just like in lists, each item in a tuple has a position number called an index. And as you know, Python starts counting from 0. You access tuple position exactly in the same way you access list position, by calling the tuple name and placing the position inside brackets. A tuple also can hold integers, strings, floats, booleans, or even a mix of different types. Since tuples are immutable, you cannot change an item after it's created. This is different from lists, where you can modify the contents. Since you cannot modify a tuple directly, you also cannot add or remove items once it's created. However, you can convert a tuple to a list, modify the list, and convert it back to a tuple. Are you curious how? Step 1. We have a tuple called fruits, which holds 3 items: apple, banana, and cherry. This tuple is immutable, meaning we can't change it directly. Step 2. We convert it into a list. Here's how. We use the built-in list function. Super easy. Just come up with a cool name for the new list. I went with something super creative. Then use the function and put the tuple name inside the parentheses. Once you've got your list, go ahead and make the changes you need. For example, let's say we want to place orange into the first position. When you're happy with your shiny new list, it's time to turn it back into a tuple. The process is almost the same, but this time we use the tuple function instead of list.
Simple as that.
Just like with lists, you can use a for loop to iterate through the items in a tuple. A set is like a unique collection. It's a bit like a list or a tuple, but with a twist. Sets can only contain unique items. So, no duplicates allowed. If you try to add the same item twice, Python will just ignore it. To create a set, you follow a similar idea to lists and tuples, but this time, you use curly braces instead of square brackets or parentheses. Now we have a set named fruits with 3 items: apple, banana, and cherry. One important thing to know: sets don't care about order. The items in a set don't have a specific index like lists or tuples, so if you print a set, the order of items might change every time and can't access the items based on index. You can only add or remove. To add an item to a set, you use the add method. You can only add one item at a time, and remember, if it's already in the set, Python will just ignore it. If you want to remove an item, you can use the remove method. If the item isn't in the set, Python will throw an error. Alternatively, you can use discard, which works even if the item isn't there. One of the most powerful things about sets is that they automatically remove duplicates. For example, even if the list contains a lot of duplicates, once called will remove all and print once one different item. So, to summarize, sets are unique collections with no duplicates. They use curly braces to store items. You can add and remove items easily. Order doesn't matter in sets. A dictionary is like a real-world dictionary, but instead of words and definitions, it stores key-value pairs. Imagine you have a list of items, and each item is linked to a specific description or value. That's what dictionaries do. To create a dictionary, we use curly braces, just like sets, but this time, we separate each key and value with a colon. Then, we separate the key-value pairs with commas. Here, person is a dictionary with 3 key-value pairs. Name is the key, and John is the value. Age is the key, and 30 is the value. City is the key, and New York is the value. To access the value associated with a key, you simply call the dictionary name and pass the key inside square brackets. Whenever you want to add new key-value pairs or update existing ones, you can use the same syntax. You simply call the key you want to change, assign a new value using the equal sign, and voila. How does this work? If the key does not already exist in the dictionary, it will be created with the value you've assigned. But if the key already exists, the value will be updated to the new one. You can remove an item using the del keyword or the pop method. Just like in real life, dictionary keys must be unique. You can't have two identical keys in the same dictionary. However, the values can be duplicated. Recap. Dictionaries store key-value pairs. Use curly braces to create them. Keys are unique, but values can be duplicated. You can add, change, and remove items easily. Looping through a dictionary gives you both keys and values. The open function takes two parameters, file name and mode. There are 4 different modes for opening a file: read, append, write, and create. I will go through each of them one by one and highlight the key points you need to know. Read is the default mode when no specific mode is mentioned. It opens a file for reading and returns an error if the file does not exist or if the path is incorrect. Append opens a file for appending if it already exists. Otherwise, it creates a new file. To specify this mode, simply place an A after the file name. Write opens a file for writing if it exists, and if it does not, it creates a new file, similar to append. To use this mode, place a W after the file name. Create is used to create a new file but will return an error if the file already exists. This mode is specified by placing an X after the file name. Additionally, you can specify whether the file should be handled as binary by using the letter B or as text by using the letter T. It is important to note that text mode is the default. For example, the code above is the same as the code below because R for read and T for text are the default values, meaning you do not need to specify them explicitly. Now that we understand the basics, it's time to get hands-on. Open your IDE and, in the same folder as your main Python file, create a new text file with some dummy text in it. To access the file properly, we need to create a variable to temporarily store the data, allowing us to read and modify it later. In this case, I will simply use file as the variable name. We assign it using an equal sign and call the open function. Inside the parentheses, we first specify the file name, don't forget the quotation marks, and then the mode we need. In this case, we can either leave it as is or explicitly use R, since it's the default mode. Next, in the print block, we use the variable name and call the read method. Note that if the file is located outside the current folder, you need to provide the full path to the file. One interesting feature of the read method is that you can specify the number of characters to read by passing a number inside the parentheses. For example, if you use 5, it will print only the first 5 characters. Since Python excels at handling data, it provides additional methods for reading a file. One particularly useful method is readLine, which reads an entire line at a time. A good practice is to close the file once you are done working with it. You can do this by calling the close method. Only reading a file is boring, so let's edit and create new ones. To do this, we can use append or write mode. Replace the R mode with A to append more text to an existing file. Now that we have the ability to write, let's use it with Python's built-in write method. Use the variable name followed by a dot and call the write function. Inside the parentheses, place the text you want to append. Don't forget to close the file when you're done. This allows us to reopen it in read mode without any errors. Unfortunately, we can only use one mode at a time. This means that after appending, we need to close the file and open it again in read mode. There is a way around this, but since our goal is to understand the basics before diving into pandas, which simplifies file handling, there is no need to spend time implementing it now. We can also use write mode instead of append, but be careful because this mode will delete all existing content in the file and replace it with the new text you write. Make sure you don't accidentally overwrite important data when using write mode. Always double-check that you really want to replace the contents before using this mode.